Hey guys, welcome back. Today we are going to deal with the breathing board, exactly the one you've seen in the black cube in the last two videos. And we're going to see what do you need to make it working. Let's start it. If you just pick up two digits like these ones and you energize them, here I have two acrylic boards just because the brightness is too high on them. Okay, so if you just energize these two digits, of course you're going to see the number, and the number is according to the mini dip switches we mounted a couple of videos away. So these ones are going to improve obviously the digit because you can change the numbers as you wish. So you know that already. But the point is not to energize these ones just to see the number, but to use the breathing control board, this one here, in order to make it breathing, okay? So how do we do that? Again, this is exactly like the one mounted already in the black cube. So before discussing diagrams, let's see if we mount it. How is this working? Here is going to be the power supply. So we don't need to energize directly the digit. We need to just energize our power supply of the board, make the connections, and now the two digits, as you can see, there's nothing else on this board, nothing else but just the two digits are going to be energized from our board. Okay, so from our board is going to be like this. We put all the anodes, all the cathodes together. So all of them are going to go with the same pace. In the moment I'm going to energize, you just have to give it 1-2 cycles until the capacitor starts to charge and discharge. We good? So now, because this kind of number is on the house, you need it to be visible at all times, okay? So take a look. Now it's breathing faster. You can clearly see the brightness goes lower and higher. Okay. Don't worry about the clarity because it's just the distance between the acrylic board and the digit, okay? It's just to reduce a bit the brightness, okay? You see? So when you turn the potentiometer, the breathing is much slower now, but the number remains visible at all times. Later on, I'm going to show you another kind of prototype, but this one, it does exactly what it should. So that's exactly like the one mounted, like the board mounted in the black cube, okay? Very good. So if it is working, now let's see now how is this made. I'm gonna start with a very old diagram. Published by Bill Bowden. Many years ago. And based on this diagram, we're going to add some bells and whistles to make it working as we wish. The diagram is based on two operational amplifiers. Here we have two resistors, 47 kiloohms. We're going to energize our diagram at 12 volts. Actually, the original diagram made by Bill Bowden was powered at 9 volts. You won't make a difference because the op-amps can be energized somewhere between 4 to 15 volts easily. Okay, so any such operational amplifier has two inputs, non-inverting, inverting. Here is going to be right the opposite, inverting and non-inverting. And the whole diagram actually is based on charging and discharging a capacitor. So the problem with that capacitor here, in the original diagram it was something like 22 microfarads, but non-polarized. NP stands for non-polarized. So it doesn't have polarity plus or minus. That capacitor is not easy to find. We're going to find out how to overcome that problem later on. So here it was a resistor. The original one was 47 kiloohms. And then there were two transistors. One of them was NPN, and here there were two diodes in series, two LEDs, and then it was another transistor. This one was PNP, so somewhere here it was plus 9 volt, and this one also had two diodes in series, and of course the limiting resistor. So this was a PNP transistor, low power, any low power transistor. This was a NPN, and here from the output of this op-amp you are taking the signal and energizing the two transistors. So if I just put here the type of the op-amp is LM1458, very easy to find, I'm going to show you later on. Here it needs these two wires, they just cross each other but they don't touch, because this is the pin number 4 for the ground, this is the pin number 8 for the VCC. Now if we number these pins, it's going to be like this. The output is on the pin 1, here is going to be like that. So this package has two operational amplifiers. It has 8 terminals. So all the 8 terminals are here. That was the original schematic, and everything was based on charging and discharging that capacitor. I'm going to put on the Google Drive a summary of the description of the whole functioning. But the thing is, this op-amp, it delivers a kind of ramping wave. So the capacitor slowly charges and discharges, slowly charges and discharges, and so on. And the second operational amplifier, it establishes a comparator actually. So here is half of the voltage of the power supply. If the voltage is 9 volts here, you're gonna get 4.5. So this level here is compared versus what's coming right here. So anytime that voltage is lower, the output is go low. Anytime the voltage is higher, the output goes high. Very easy. So it's going to control through that resistor the charging and discharging of that capacitor. So the thing about that is, through the output of this second op-amp, you're going to change the direction of charging that capacitor. This is why the capacitor has to be non-polarized. Now, I took this diagram, which is pretty easy to make. It's only one package, okay? And I modified it a bit, okay? For this one here, I added some bells and whistles, so I'm going to draw it again, because this way you are going to be able to compare the two diagrams, and you are going to see what we did. This time is 12 volts, simply because when we have to energize our digits, they require 12 volt, okay? So it's going to be pretty similar right here. We need the two amplifiers. Okay, so the first amplifier here, the second, now here is the problem with the capacitor, and in order to overcome the problem, we're going to put here a notation. Let's call this A and B, the two ends of the capacitor. Okay, so pin 3, pin 2, pin 1 the output, pin 6, pin 5, pin 7 the second output. Okay, so right here is going to be the resistor. This, instead of being 22 microfarads, we're going to make it 10. And we're going to increase the value of that resistor. Let me just put the values here for the ones we know. 47K. And here we're going to add a potentiometer. This one is going to be around 500 kiloohms, is a trimmer. It's exactly this little guy here you put on the board. So it doesn't have a knob to turn it. You're going to turn it with a little screwdriver. So you establish the pace you wanted, it remains like that. Or you can use an external potentiometer like the one I placed on the black cube, and it's going to be this one here, also 500 kiloohms, but you see it has an arrow here. It does not end with a short line like a trimmer. And this potentiometer, here are the bells and whistles. Here I'm going to put 100 kiloohms. It's going to be in series with either this or that. So if you use this kind of potentiometer, the trimmer, you're going to place here a little jumper. So the output of the op-amp is going to be connected to that potentiometer, which is the trimmer on the board. Or if you put it in the high position here, you're going to connect it to the external potentiometer. However, for the external potentiometer, I have another jumper here or here, simply because when you turn the potentiometer, some people prefer when you turn it to have a shorter duration. Now is a shorter duration. And some others, when they turn it, they want to have a longer duration. So depending on what you want, you're going to have the two jumpers. You take a look right here. This little green jumper is for the top potentiometer, for the top position of the potentiometer, this one. And you can put it in the bottom here. Anytime you want, you can remove it and placing it here in the bottom. Okay? But if you do, it's going to change the way the potentiometer is working. And the second jumper, the red one, it makes the switch between the external potentiometer and the trimmer on the board. Okay? So, just to offer you maximum flexibility. And now for the output, we don't need these little LEDs on the board. I put them there just in case for the fun of it. But what you actually need is this. Here is okay. Now we have the limiting resistor and only one diode. So this is an LED. This is 1 kilo ohm resistor. And this one goes to the plus 12 volt, the collector. And the second transistor actually is going to be triggered using a 22 kilo ohm resistor. And then it's going to be also an NPN, but connected like that with the emitter to the ground. And here in the collector is going to be our load. What is our load? The two digits together. And here is the plus 12 volt. Okay? Where the two transistors take the signal from to trigger the base? From the pin 1 of the output of the first op amp. One from there, one from here. Now, what kind of transistors can you use? For this one here, any little NPN like 2N2904, 2N2219, European model BC547, just to give you a couple of examples, but it's a general purpose transistor. You can use plenty of them. And for this one here, because this one is going to support the load, which is the digits, and the digits may have a consumption of between 1 and 200 milliamps. If you put here a TIP31, TIP is from Texas Instruments power transistors, TIP31, or later on you can even use a Darlington like TIP120, okay? So it's plenty of choices you can have, okay? But the second transistor, the power one, is energized, is triggered through a 22 kilo ohm resistor, okay? So basically that's the diagram. So if I add here the same pin 4 and pin 8 for the VCC, here is the inverting input, the non-inverting. Here is the non-inverting, here is the inverting, okay? And it's the same kind of op amp, 1458, okay? So this one here, that version, contains all the adjustments you may want in order to make it working as you wish, and making adjustments instead of making them on the breadboard, to make them directly on the printed. And if you can see, the printed board here is nicely made. There are no external wires coming on the top. Please be so nice and let me know if you just drop me a line in the comment with your email address. I'm gonna send you the 2 pages. This is the component side and this is the solder side. So exactly how the components are arranged on these boards. Now quickly, very quickly, how to overcome that problem with the little capacitor here, which is not easy to find. Actually is right here, this one, exactly the original capacitor. This is a non-polarized capacitor, but it's the last one I have. So starting next time, I'm gonna use electrolytic ones. So I'm gonna draw them here. Between the point A and the point B. Because we don't have this one, is difficult to find, this is what we're gonna do. We're gonna use 2 electrolytic capacitors. I prefer to use tantalum ones because they have low leakage, but we're going to put them against each other, okay? So each of them is going to be 22 micro, 22 micro. And as you know very well, when you put capacitors in series, they are not like resistors. The total capacitance, which is going to be the capacitance between the points A to B, is going to be half of the value, around 11 microfarads. So again, it's not like resistors, okay? The advantage is, though, you can use them at lower voltage. So if each of them is 16 volt, it's just perfect, because the power supply being 12 volts, they're going to work fine, okay? Usually the tantalum capacitors should be used at no more than half of the voltage printed on the body. So you'll have no problems at all because they are in series, okay? So this is the arrangement you can use to replace the original capacitor, which is non-polarized, and you're gonna make one yourself like this, okay? And because I'm here, I'm going to remind you again, you don't need both potentiometers. You can only pick up one of them. But I put both of them just in case to have maximum flexibility, a trimmer on the board, and an external potentiometer if you want to mount it on the black cube, okay? And remember again, if you drop me a line with your email address, I'm going to send you both files. One containing the arrangement of the components from the top, and the other one with the solder side, because when you flip the board like this to solder, you have to see exactly how to do, so you can see exactly the drawing of the same circuit in a mirror, okay? Very good. So now, you've seen how this one is working here, and this is because I prefer to use very visible light for the digits, you see. So the brightness goes lower, but it does not go completely off, okay? Simply because the number is going to be mounted on the house, it has to be seen all the time, okay? So this is why the adjustments, okay? So far so good? So if this is done, then what we're going to do, I'm going to show you another kind of circuit, which is not far from this one, but the function is a bit different, okay? A little note, how did I connect the two digits here on the breadboard? There is an adapter, the one I'm still waiting to be delivered for more than 1 month, and because I'm a bit fed up, I'm going to show you next time how can we build one ourselves and not wait for it, okay? So that's a very special adapter. We're going to make one next time, okay? Right now, using a similar diagram, just with few modifications, we're going to shut this one down, okay? We open the circuit here. Don't need this one anymore. Power supply is going to be disconnected, okay? We put it away. We move our breadboard. We pick up our acrylic board. No need anymore. We pick up our 5 inches digits. Okay? And now we pick another one. Okay? So that's a bigger digit, the 7 inches, exactly like the one on the house. Here, just for the purpose of showing you how is this working, I only have one mounted, okay? That's an older prototype. For this one, I even combined the arrangement of the two capacitors in series with a non-polarized one. And here is a kind of Darlington transistor here, 2N6039, this one, 2N6039. The one I was giving you before, TIP120, is also a Darlington, but is a bit stronger. So let's add this one here if we want. I can use a 2N, is right here. You see? Is right here. You can easily see it. Okay, 6039. Okay, 6039. Or you can use another model if you want. Okay. For this one, it's an older prototype. You see, it's plenty of wiring on the component side. It's not that nice, but it doesn't matter. It's fully operational. Here I connected the digit. As you can see, all the anodes, all the cathodes are together through the mini dip switches. Okay. So I picked up a number here to see. And here we're going to connect the supply. We're going to connect the supply. in the black cube, we have our own supply. Here we're in the lab, so we have a bench power supply. So now, when I'm gonna put it on, okay, so now you have to take a very close look on that, because the way this one is working is pretty particular. You just take a look. It goes very bright, take a look at it. And then it goes slower and slower until it goes completely off. I exaggerated with the components just to show this to you. I had this mounted years ago, but because sometimes the delivery guys, they couldn't see the number simply because it was going off for too long. They didn't know the house number, so I decided to make the other version in the black cube. But this one, if you take a look, some people may like it, okay? Because of the high value of the capacitors, the brightness goes completely off and then back on. You see this? So playing with the components, you can do any kind of arrangements you want. Even this one here, take a look how bright it is. It can be even seen in the sunlight. Okay, I had it on the house for many years. Okay, and it doesn't matter. I only have one round mounted. You can mount 2 or 3, depending on how many do you need. Okay, good. So another file you are going to find in the folder on the Google Drive is going to be with the components you required for this project. So you're going to get the diagrams. You're going to get the original, an extract from the original file published by Bill Bowden years ago. And you're going to have on request the circuit in order to wire it if you need it. Okay. And now the last thing we're going to discuss, we go over the computer. And I'm going to show you now on the component list. Okay. So I'm going to give you the whole parts list of that project. Okay. It has a lot of little things on it. The prices are considered an estimate, or they are approximated using basically one of my favorite sites, abraelectronics.com. But right here, what's most important is the 7 inches size 7-segment display module. Okay, this one you are going to find easily on qkits.com. So if you're just going to click here on the link, you go right there. So just to save time, I'm gonna go myself there. Here is the 5 inches. Here is the 5 inches digit, this one. And if you go, let me see where it is. Right here. Here you're going to find the 7 inches, exactly this one I have here. So the price for this one is pretty reasonable, is around 47 Canadian dollars. It's pretty low compared to any other site you go. Okay, it's a very good price. And that's exactly the one I put here in the document. This one here, it's around 47 Canadian dollars. You need 2 of them. If your receiving number is made of 2 digits, you are going to need 3 of them if you need more, and so on. So then you are going to have all the components here, including the potentiometer, the trimmer here. The prices are very reasonable. So for some of the components, I gave you the link exactly where you find them, okay? And for some others, you can find them anywhere else. You may even have them in your junk box like these resistors, which I put them here, okay? So I put here the components to replicate exactly my black cube you've seen in the last 2 videos, okay? And you're gonna get this one online attached to the project, okay? So remember, what about next time? I have here a special adapter for the breadboard, but this one has 26 pin. I have another one here, 14 pin, but what I'm missing are the most important ones, the 16 and 20 pin. And because I'm keeping waiting for them and they are not available anymore, for some reason, we're gonna make them ourselves next time. So far so good. Thank you very much, guys. See you next time. Bye-bye.